Doom, 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 doom. Oh, it's on already?
Yeah.
Oh, hey guys, hey class, how you doing? Doing a little maze here. This is Mr. P, and I like mazes and puzzles and factoring. Okay, yesterday we did factoring quadratic expressions, and today we're going to do factoring polynomial expressions, and I'm going to show you. Just like quadratic expressions, there's nothing to be afraid of. Let me just finish this maze right here. There's few things that make me afraid, right? So, you know, I ain't a sucker, so I don't need a bodyguard. Doom, 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 doom. Can I make it through here? Let's see. Can I make it up here? Almost, almost, almost. Here we go. Do do do. Oh! Whoa! What the heck? What the heck was that? Oh my goodness! Hold on. Stay right there. Everything's okay. Everything's okay now. Let's put that away. Look. Okay. That's something you can be afraid of right there. Okay? Don't worry about that. But this is something that you shouldn't be afraid of, okay? Especially if you're an algebra student, okay? If you know how to add and subtract and multiply, this should be no problem. Okay, so let's start looking at a problem here. It says solve by factoring if one of the factors is x minus 3. As we learned from the last lesson, okay, when you factor expressions, you're usually left with binomials, okay? The same expression broken up into binomials. I'm just going to add a little more light here, and I have my trusted camera assistant Nina.
Woo!
Thank you so much. And it's snowy outside, so we're just going to use this time to get some work done here. Okay. Now, if we have to factor this, well, this crazy looking expression, which may look scary, but it's really not that scary because we've already been given a clue. We were told one of the factors is x minus 7. Okay. What does that mean if one of the factors is x minus 7? This is really important that you get this. Okay. If one of the factors is x minus 7, okay, then we have a couple other factors. We don't know what they are, okay? But this is a third degree polynomial, so we know there are going to be 3 x's multiplied by each other here. So this times another binomial equals 0, okay? So we're going to try to figure out what those other 2 binomials are. But when you're saying that this is, one of the factors is x minus 7, one of the things you can be sure of is that if you popped in the opposite of that, if you popped in a certain number here, it would turn this into 0, and 0 times this would be 0, and 0 times this would be 0, so you would get your answer. So what do you think the number is that you can pop into that x? What's the value of x that would make this binomial turn into 0? Well, the question is, what minus 7 equals 0? What minus 7 equals 0? Nina, do you know that one? What minus 7 equals 0? Any idea?
What?
Oh, you're just filming, huh?
Yeah.
all right, she's just filming. So, okay, I don't want to mess her up with the filming. But there's a number that if you subtract 7 from it, it equals 0. Do you know what that number could be? Well, 2 minus 2 is 0, right?
Yeah, I know.
3 minus 3 is 0.
7 minus 7.
7 minus 7, you got it. There you go. So the answer is 7. So if you pop the 7 in for x, 7 minus 7 would be 0. That would turn that into 0. Times anything is 0. It becomes 0. So 7 is one of the solutions for this polynomial. Okay? So what we call that solution is we call it a 0. Because that's a number that would make this turn into 0. Okay? So if x minus 7 is one of the factors, okay? So that means that 7 is one of the zeros. We call it a 0. 7 is a 0 because x minus 7 is a factor. Okay? If x plus 4 is a factor, we don't know that, but if it is, then do you know what the number that would go in there would be to make it go to 0? The opposite. That would be negative 4. So negative 4 is a 0. If. That's if. I'm just giving you an example here, but let's go back to our problem up here. Okay, so we know that 7 is one of the zeros. So what we can do with that information is, okay, what we want to do basically is this. Since we know what one of the factors is, we can now divide this whole polynomial expression by x minus 7. So we can go like this. We can go x cubed plus 6x squared minus 51x minus 280. Ooh, I'm going to want to hold this up a little, right? And we could divide that by x minus 7, just like this. Okay, we put that in parentheses. Now, if we can divide this polynomial by x minus 7, we're in business. We can use long division, but guess what? I'm going to use something called synthetic division, which is a lot quicker. Okay? So we're going to use synthetic division, and how does that work? Well, let's write this down. Synthetic division. Okay? We take the coefficients of all these terms here. Okay? And we have to make sure, okay, this is the dividend. We'll take all the coefficients here. We have to make sure that all the terms are present. X to the third, the next would be x to the second, the next would be x, and the next would be the constant. If any of these are missing, we have to put a 0 in there as a placeholder. But in this case, none are missing. So what we're going to do now is we're just going to write down those coefficients. The coefficient here is 1. We don't see it, but we know there's a 1x cubed. So we put the 1 there. The next one is a 6. We put it there. Next one is a minus 51, which makes negative 51. And the last one is negative 280. So we put negative 280. Okay? And here's what we do. Put that down there. And now, since the factor is x minus 7, the 0 is what we're going to put right here. The 0. What's the 0? We said if x minus 7 is a factor, the 0 is 7. So now all we do, we're in business, we're ready to go. We drop the 1 down. Let's parachute it down. I usually draw a parachute in class so kids could see this little guy going, falling down. That 1 comes down right here. Put it down there. And now all we do is we say 7 times 1, we multiply it, is what? You know 7 times 1?
7.
7, good job. 7 times 1 is 7. So we just put that right up here in the next column underneath the 6. So now we have 7 times 1 is 7, we put it there. And then we go 6 plus 7 is 13, we put that right there. And now we do 7 times 13. Ooh, that's going to be a pretty big number, but you can use a calculator. I don't mind. It should be 91. So 7 times 13, we multiply it through. 7 times 13 is 91. We put it there. And now we add these two. 91 plus negative 51, or negative 51 plus 91. And they're different signs, so we subtract and take the sign of the bigger number. We should be left with 40. Okay, so 7 times 40 is, oh I'm sorry, that should be 280 there. 7 times 40 is 280. When we add these two together, we're left with 0, which is perfect because there's no remainder. It means remainder of 0. That means that that was indeed one of the zeros. It made this whole term go to 0. Now, what do we do here? We take the 1, we take the 13, and we take the 40. And since this was x to the third in the first column, we're going to bring it 1 degree down. So this is going to be 1x squared. That's a positive 13, so we say plus, okay? This was x to the second, so if we bring that down 1 degree, okay, that's no longer x to the second, it's 13x, okay? And now we bring down the 40, and that's a positive 40, so we say plus 40. And that was an x degree term, so what's the 1 degree down? It would be a constant. So there we go. We just factored that big mean-looking polynomial into x minus 7 times this trinomial here. Okay? So the question is, and by the way, we were setting it equal to 0 because we want to solve it, right? Okay? But guess what? This isn't fully factored. We still can't solve. We could solve this one. We could set that equal to 0. But setting that equal to 0 would be a little bit trickier. So here we go. So let's try to factor this. We know this is x minus 7. I'm going to put that aside. Now this is going to be, well, it's x times what gives us x squared? Well, x times x. So we're going to put in one of, we know there are 2 binomials here, because that's a second degree term. So we're going to put an x here and an x there. This is like reverse FOIL. This is factoring a regular quadratic expression now. So now we want to know what are the factors of 40 which add up to 13. And we're going to put those here. Well, look at this, factors of 40. How about 20 times 2? That's a factor of 40, but that adds up to 22. That's not what we're looking for. Sorry, goodbye. How about 4 times 10? 10 times 4. That equals 14. That doesn't add up to 13. It's close, but that's not the one. How about 8 times 5? Wait a minute. 8 times 5 multiplies to 40 and adds up to 13, which is just what we're looking for. Huh? So that looks very nice. So we're going to put plus 8, plus 5. We just factored that trinomial, and when we put it together with that first binomial, we just factored this whole mean-looking polynomial. Yeah? It doesn't look so mean anymore, does it? No, I don't get shaken with this kind of stuff. Look, and you shouldn't either. If you can add and subtract, what did we do here that was so out of the ordinary? We added, we subtracted, we multiplied, nothing more. Just if you learn these steps, you're going to be able to solve these types of problems by factoring. So we set it all equal to 0, which is what our original problem was asking us, right? Set it equal to 0, and, well, do you remember the trick? We set the first binomial equal to 0, x minus 7 equals 0. We solve that, we get 7. X plus 8 equals 0. What plus 8 equals 0? Doom, 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 doom. Isolate. Subtract 8, x equals negative 8. So that's another solution. How about x plus 5? We set that one equal to 0. X plus 5 equals 0. Subtract 5, x equals negative 5. Doom, 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 doom. We just solved this original equation, which was asking us to find out what inputs make it equal to 0. Okay? So what are the inputs that make this equal to 0? Okay? We just solved them. The answers are, I'm going to write it nice and neat. The answers are x equals 7, x equals negative 8, and x equals negative 5. Thank you. Hello. Okay? You can check that by evaluating each of these terms. You could pop it in. Okay? Pop it in. Pop in a 7. See if it gives you 0. Pop in a negative 8 for x's. See if it gives you 0. Pop in negative 5 for all the x's. Evaluate and see if that gives you 0. It should if we're correct. Okay? So, I hope you got that. Let's do another one. Ready? How about this one? Ah! Did that scare you? Okay, don't be scared. If you're in Algebra 2 class and you're sitting there and your teacher says, solve this, okay, don't worry. Just say, hold on 1 second. Let me go home. Let me check my YouTube video, and I'm going to just walk through these steps here, because I could solve that. I can do it. Ready? And let's start right here. Let's start. This time we're given a different clue. We're told that one of the zeros is negative 3. Okay? So you